When dealing with propagation of uncertainties, there are two ways to apply this. So first, we're going to deal with addition and subtraction. So first, when we're dealing with decimals, we simply use the one with the most decimals. For example, let's say we're doing 5 minus 1.01. All we do is, since 1 has the most decimal places of 3, so this would be 0 and this would be 3, we could write this as, we write that it's 5.00 minus 1.01, and then we can solve like you would normally solve, so this would be 3.99. But when we're propagating uncertainties specifically, what we do then is we propagate the absolute uncertainty. For example, let's say we have a figure such as 5 plus or minus 0.01 plus 3 plus or minus 0.002. Now the first step is we're just going to add them. So 5 plus 3 is obviously 8, and then plus or minus this plus that would be 0.012. And now the second step, so step number 2, is round. So this, we round uncertainty, so this would be 0.01, and now 8 stays the same, so it would be 8 plus or minus 0.01. This is how we propagate absolute uncertainty. However, there's a second case. In this case, works with addition and division. And in this case, we use percentage uncertainty. Just a reminder, and this will be in your formula booklet, of course, percentage of uncertainty is absolute uncertainty over the total times 100%. So for example, if you have 50 plus or minus 10, that would be 10 over 50 times 100%. So that would be equal to 20% uncertainty. And because addition, multiplication, and division, the relative functions, we need to use these because they don't clearly translate. So let me give you an example. So in this case, what we do is we add percentages. So let me give you a more clear, simple example. Let's say we do 5 plus or minus 1% times 10 plus or minus 3%. What we would do is we would multiply 5 and 10, so 50, and then 1 plus 3 is 4, so 5 plus or minus 4% would be the final answer on this. And then of course we can also write this, it's a good practice to write also the absolute uncertainty. 4% of 50 is 2, so this would also be 50 plus or minus 2. So that's how you generally propagate it, but things can get a bit more complicated. So let's say we want to do a situation where it's 10 plus or minus 2% to the power of 3. Well, because we're multiplying 3 times, because we're adding 3 times, it's going to be 2 plus 2 plus 2. So it would actually be equal to 2 times 3. So here we have a rule. Let's say we have a value to the power of n. The uncertainty is just going to be the original uncertainty times n. So in this specific case would be 1000 plus or minus 6%. Now this may seem easy, but reminder, sometimes you need to convert absolute uncertainty to percentage uncertainty. So let's say we have a value such as 3 plus or minus 1. Well, first we'd convert this to 3 plus or minus 33%. And then we can do calculations such as 3 plus or minus 33% times 5 plus or minus 2% would be equal to 15 plus or minus 35%. Again, this will all be relatively simple. Just need to do some practice. Also, this is also another reason on why oftentimes in like IAs, if you put something to the root of something, it can be beneficial. Let's say you have a value 10 plus or minus 1%. If you put it to the half, the uncertainty will actually half, because reminder, it's times n. So in this case, it would be square root of 10 times only 0.5%.